Hi, everybody. I have a special section for you today. We're going to be doing BB.15, which is to write a quadratic function from its vertex and another point. There's a bunch of ways of looking at this, but I'm going to start out by making a connection with the point slope form that you're probably familiar with. Now, you may not have been taught it this way in your class. You might have used HK, and I'll make that connection on the next problem. But on this first problem, what I'm going to do is I want you to remember that if I were talking about 2 points and I wanted to look at the point slope form, the equation looks like this: y minus y1 is equal to m times x minus x1. And if I were looking at 2 points, I would immediately realize that I needed the slope between the 2 points, and I could write the equation if I just had the slope. And we actually would have started with y minus y1 over x minus x1 and got the slope. And we're going to do something very similar. The only real difference is that our x terms are being squared. Everything else is pretty much the same thing. So what we're going to do is we're looking for this m. Now your instructor is probably going to be calling it a because that's the leading coefficient on the x squared term, and that's sort of what we're looking at. Another reason they don't call it m is because it's not really a slope. It's more of a stretch or compression factor. But anyway, the idea is the same though. I'm just going to substitute this in. Now, I recommend that you keep it straight. You always go in the same direction. So the direction I'm going to go in is I'm going to do the y minus y1 and x minus x1. Now, it doesn't matter if you go the other way, but I'm just going to be consistent, I'm going to start as this one is going to be the first term, and then I'm going to subtract this one. It doesn't matter. It's probably more consistent that way. So anyway, we've got 5 minus 0. And again, you could call this a or m or n or any variable. It doesn't matter. I like m for whatever reason. I'm just going to leave it as m. Next time I'm going to call it a. So anyway, x is, remember we have to start over here, -10 minus 0 quantity squared. So what we end up with is m times -10 squared is 100 is equal to 5. And we're going to divide by 100 on both sides. Now be careful, you do have to reduce your fractions. So my m, or rather my a, my stretch factor, is 5 over 100, which of course you could write as a decimal. Okay, it says simplifying fractions. They probably want it as a fraction, but I could just as easily have written it as 5 hundredths, which is 0.05, or 1 over 20. Now we have to go back and do the same thing we did with point slope form. Now, obviously, this is going to be the easier point, but I'm going to write it both ways so that you can see what I mean. Now, since they want it in vertex form, we're actually supposed to use this one. So I'm going to do y minus 0 is equal to the m, or the stretch factor, times x minus 0 squared. Now, for the bad news, they don't like this particular version. They prefer that you add the y1 to both sides. So we have to do that at the end. And we have to simplify this anyway a little bit. So this is going to be 1 over 20 x squared. And normally I would have to add the 0 to both sides. But since it doesn't change anything, it's just 1 over 20 x squared. Now, there's a more intuitive way to do this, but maybe later in the section we'll try it that way, okay? So there it is, x squared, and that's it. Now you can check this by substituting both points in. 0, 0 clearly works, and if you put in the -10, 5, you're going to see that you actually get the right answer, and of course, it has to work for both points. But we want it in vertex form. So that's an important idea. Okay, I'm going to do the same thing again. This time I'm going to use a instead of m. So I'm going to do 0 minus 4. Notice I'm subtracting the y's, is equal to -4 minus 0. Make sure you go in the same direction. Now I know because you're subtracting and you're squaring, it doesn't matter, but I think it's a good idea. And again, like I said, I was going to call it A instead of M. Sorry, I kind of made it a little small there. So this is -4 is equal to A times -4 squared. Be very careful. Don't grab your calculator and put this into it, because this is -16 and this is +16. For those of you that are familiar with my videos, you know I keep reminding you of this. The bad idea is using a calculator when you don't need it. So that is going to be A times 16 is equal to -4, and we're just dividing by 16 on both sides. I am going to do this a little quicker in the future. -4 over 16 is -1/4. And again, I could have just as easily put a decimal, -0.25. And again, we have to go back to our equation. Now, I like to think of this vertex as a y-intercept, because it really is a y-intercept in this particular case. Now, in this particular case, we're going to have y minus 4 is equal to -1/4 x minus 0. And what they do is they go ahead and simplify squared, sorry, -1/4 x squared, but they simplify it by adding the 4 to both sides. I'm teaching this for a reason, and it's because I want to make a connection for you later on with if we get into conic sections. So I'll make a connection with conic sections and this, and show you why this is really, this one up here that I like is better than that one. But anyway, there it is. So we have y equals, I'm going to use the fraction so it doesn't mess it up, -1/4, and I'll erase it so you can see it a little better, x squared, and then we have the +4. Oh, darn it. Oh, I gotta get up in there. There we go, x squared, and then +4. Let's make sure I erase it so you can see it a little better. There it is. So we have a -1/4 times x squared +4, and there it is. I know it took a while. Sorry about that. It's a little slow. So let's do a faster one this time. So I'm subtracting my y's. That's 2, careful. Remember, I'm subtracting a -7. So that means that we've got 2 plus 7 is equal to -6. Oh, I got to put my a in front here. I want to make sure it's clear. I'll call it a instead of m. It doesn't matter though. -6 minus 0 squared. So that's going to be a times 36 is equal to 9. We're dividing by 36, and we get a equals 1/4. We're almost done. Now we just have to put in our equation. Now, the shortcut for this, of course, is to just think of this as, since when x is 0, y is going to be -7. So we know we've got y equals 1/4 x squared minus 7. And I could just shortcut it a little bit. So there it is. Hopefully you can see where I got that from. 1/4 x squared minus 7. I'm putting the space for the -7 in case they think I'm multiplying instead of subtracting. There it is. So pretty little thing there. The thing I shortcutted was the substituting in the h and k business for the vertex form. Some people like to think of this as h comma k. I promised I was going to do this. H comma k, and their vertex form is y equals, I don't like this vertex form, but here it is anyway. It's a, sorry. We've got some a times x minus h quantity squared plus k. Now, I prefer to put the y minus k, but some people like this particular version. I found the a using my technique similar to finding the slope. And then when I find my a, I substituted. So my a was 1/4 and x minus hk, so x minus 0 squared, and then plus the k is the -7. So that's 1/4 x squared, because that's x minus 0 squared minus 7. So there's the connection with the HK business, if that's what you needed. Hopefully that's clear. So we'll try it one more time. Now, this one looks a little more complicated. We've got 15 plus 5, 3. What's wrong with me? 15 plus 3. I'm subtracting a negative 3. That's plus 3 is equal to 12 minus 0 squared times a. If you wanted to see this, I'm doing this. I'm doing, a lot of people would be putting the minus 3 out here because they would be doing y equals a times x minus h squared plus k. But I prefer to think of it more like the point slope form. So what I really did was I did y minus k. I'll write it down here maybe. Y minus k is equal to a times x minus h quantity squared. So I'm doing this one instead of this one, but it's the same thing. There's no difference. The only difference is that they like to add the k to both sides. I have a reason for writing it that way, so there you have it. 15 plus 3 is 18, and that's equal to a times 12 squared is 144. I would have probably just left it as 12 times 12 when I divided. I would have left it, instead of putting in 144, like, I would have left it like this, 12 times 12. It's just easier to reduce that way. I would have reduced it in my head, but instead of thinking of it as 144, I would think of it as 12 times 12. So then when I simplify it, 6 goes into 12 2 times, and 6 goes into 18 3 times, and then I simplify the 3 with the 12 and get the 4. So that's 1/8. It's a little easier to see than the fact that 18 goes into 144 8 times. It's a little hard to see that. So anyway, there it is. A is 1/8. And again, this is the one they want, and there's your vertex. So it's just simply 1/8, x squared minus 3 equals 1/8 x squared space minus, darn it, 3. There we go. And you can check it and everything, but I'm pretty sure it's right. It's the 1/8, and then we just have to get the vertex in the right location. And we know if x is 0, y is negative 3, and we can see that it works really well there. There is a shortcut I could use for this that I can see. The problem is that it only works when your vertex is on the y-axis, and it gets really complicated and hard to think about because I can see already what my stretch or compression factor is based on the numbers. We may get to that, but for right now, I'll just go ahead and do the 6 minus 3 equals a times 6 minus 0 squared. So we got 3 is equal to 36a. So a is equal to 1/12. I'm cutting some corners there. If you need to stretch it out a little bit, go ahead. And of course, that's going to give me y equals 1/12 x squared plus 3, because I want to get to 0, 3 as my vertex. So there you go. I suspect if you're doing this section that you're really not having that much trouble with the arithmetic. So you probably are able to follow along just fine. Oh, we got a fraction. Okay, so this one may be a little more challenging, but okay, we'll do the 3 plus 3. Sorry, 3 minus 0. Oh, what is wrong with me today? Okay, negative 9/4 minus 0, 9/2 minus 0. Negative 9/2. I would have just thought of it as negative 4.5 in my head. It's just easier for me, but I'll go ahead and leave it as the fraction. Minus 0 is equal to 3 plus 3 squared times a. Darn it, I keep forgetting to put the a there. Or the m, I like a better. Some people like m, some people like a. 3 plus 3 squared. I'm taking 3 minus negative 3. That gives me 6 squared is 36a is equal to negative 9 over 2. And we're going to multiply by 1 over 36. Instead of dividing by 36, I think of it as multiplying. And the 36 simplifies with the negative 9, and we get negative 1/8. And we're almost done. Once you have your A, you're almost finished, but you need to be very careful. This vertex is on the x-axis, isn't it? This is what we call an X-intercept. And so I'm using the x minus h, and that's a good way to think of it squared. So I'm going to go ahead and write the equation in HK form. So some people like it that way. A times x minus h squared plus k, just to show you where I'm getting this from, where the k is 0 and the h is negative 3. So we've got y equals the a, which is the negative 1/8, and then our x minus h is really minus a negative 3, so it's plus 3 squared, and the k is 0, so it's just plus 0. And we'll just write it like that. So we've got y equals, we have a fraction, we have a negative 1 over 8, come on, 8, and then we have to put in our x plus 3 squared, and I think we're done. So let's take a look at it and see how pretty it looks here. Okay, so we've got negative 1/8 is our stretch factor or our compression factor. The way, if I were to graph this thing, I would recognize, just a side note here, I would recognize that it's on the x-axis back here and that it's going downward. But the thing about it is that it's going downward, but it's been compressed to 1/8 its normal height. So if I were to go to 4, normally 4 squared is 16, but because we're multiplying it by negative 9 over 2, let me show you what I'm going to do. I'm going to do something weird. I'm going to go back here. From here is my new vertex, and it's going to look a bit like this. And what we can see is that going out to 3 is 1, 2, 3, 4, 5, 6 away from my new axes. I think of this as my new origin. So 6 squared is 36. But when we multiply by negative 1/8, we actually get 36 over negative 8, which it reduces to negative 9 over 2. A lot of stuff there. Anyway, I was just checking it. Oh, another fraction. Okay, no big deal. So we've got 23 over 12 minus 2 over 1 equals a times 4 minus 5, quantity squared. So this is a by itself, because this is just negative 1 squared. And 24 over 12 is negative 1/12. And that wasn't so bad after all, was it? See what I did there? I just found a common denominator for this. I multiplied by 12 and multiplied by 12 and did the subtraction. So I'm almost done. I have y equals. Now I'm going to put in the negative 1/12. That's my stretch factor or my compression factor. I've got x minus 5, quantity squared, and then I have a plus 2. And there it is. Y equals negative 1 over 12, x minus 5 inside the parentheses. I don't know if I need the space, but I probably don't, but it's better to always put it if you don't. If you remember anyway. And then I need a plus 2. And I am all done. Looks good. Now, the way you can test this is you can say, well, if I put in x equal to 5, do I actually get a 2 out of this? and I do, testing this one would be a little more challenging, but there it is. Sure looking like this one's going to take a little while. All right, so we've got negative 25 over 16. I'm going to try and write it nice and neat, 25 over 16. And what I'm going to do is when I subtract the negative 1, I'm actually adding 1. I'm going to leave it that 1 like that. And I'm going to put it over 1 like that so that you'll see what I mean in a minute here. What I did was I subtracted negative 1, which is the same as adding 1. Then I'm going to put my a, and now I'm going to take my x, negative 1, minus 2 quantity squared. So this is 9a, because this is negative 3 squared. 9a is equal to 16 over 16 gives me, what do we get here? Looks like negative 9 over 16, doesn't it? You see what I did there? I just added the 16 with the negative 25, which gives me negative 9 over 16. And the reason I did that is so that when I multiply by 1/9 on both sides, it simplifies out. That gives me negative 1 over 16. And I'm almost done. There's probably another way to do this completely different, but I'm assuming that this is probably the most familiar. So there it is. So now I'm just going to write my equation. Just like in the point slope form, all we have to do is just substitute in the values. I'll just think of it as the HK for you. So we've got y equals negative 1/16 x minus 2, that's my h, squared, plus k, so it's minus 1. So there it is. Y equals negative 1 over 16, parentheses, x minus 2 squared minus 1. And let's just make sure it looks pretty. And there it is. Negative 1 over 16, x minus 2 squared minus 1. It's a lot like doing the point slope form. If you haven't done that, probably ought to do the point slope form first, because linears are a lot easier than quadratics. Oh, big fraction. No big deal. Don't worry, it's not that scary. 153 over 16. What gets scary is if you try to do this with a calculator. You see that 16th is a really ugly decimal. Now I am adding 1, so I'm really going to add 1 because I'm subtracting negative 1. I'm going to leave it as 16 over 16 again. And then I'm going to have a, and then I have the x, negative 18 minus negative 5. So that's really plus 5, isn't it? So this is going to be 169, negative 13 squared. I'll go ahead and put negative 13 squared is 169. And look at what we get here. Isn't that 169? It sure is, over 16. And when we square that negative 13, we get 169. I'm just going to go ahead and erase it and just put the 169. And now I'm just going to divide by 169, or rather multiply by 1 over 169. Oh, how nice that is. I get a equals 1/16. So y equals 1/16. There's my HK, because I want to use my vertex. X, careful, plus 5, don't want to make a mistake right at the end, squared, and then we have the minus 1, don't we? There it is. I'm only going to go to 30 minutes, so even if I don't make it any further, I could maybe have done this a little faster. Maybe I'll go a little further, I don't know. X plus 5, quantity squared, and then we have a minus 1. I'm going to be safe and put the spaces in it. Okay, there it is. And We could test the vertex real quick. If I put a -5 in there, I do get 0 for all of this stuff here. Like, for example, if I put this -5 in here, that's all 0 and y equals -1. And sure enough, of course, the vertex works. The 1/16 is the compression factor. And we could test it with this, but it's going to be a hassle. So there it is. All right, let's see if we can do another one. Oh, this one's a little easier, isn't it? So let's do it. 2 minus 6 equals a times -4 minus 0, quantity squared. So this is 16a is equal to -4. And we divide by 16 and we get a equals -1/4. And we're just going to write it. Y equals -1/4 x squared, careful, plus 6. That's it. Y equals -1/4. We've got our x squared plus 6. Looking good. I think it's okay. Let's do one more. Maybe a couple more, I don't know. Oh, another easy one. So we've got 4 plus 1. Notice that I'm going this direction. -10 minus 0 squared. I just wanted to forget the -0 because it doesn't matter. And we've got a times 100 is equal to 5. And so a equals 1/20. I just divided by 100 and reduced. So we get y equals 1/20 x squared minus 1. Oh, got to put the x up in the right location. And don't forget your minus 1. There we go. All right. Let's at least go to the next level. Let's see here. We've got, you know what? I'm going to pause for just a minute. Take a little. I should mention that you could use a calculator for this, but what's going to happen is you're constantly going to be going back and forth with the calculator, changing from fractions to decimals to fractions to decimals, and occasionally you're going to have some errors because it's going to be simplified incorrectly. But anyway, there we have it. I'm going to subtract my y's, which is going to give me 21/4 plus 1, but I'm going to write it as 4/4. I'm just going to simplify a whole bunch of stuff all at once. I subtracted -1, which is plus 1, and then I changed it to a common denominator. I've got my a, and then I'm going to subtract my x's. I've got a 9 minus 4, quantity squared. That's supposed to be an a, not a 9. So this is going to be 25/4, and this is 25. 9 minus 4 is 5, squared is 25. So I'm going to multiply by 1/25 on both sides. And yeah, for those of you using a calculator, that is 0.04. And the 25 cancels, and I get a is equal to 1/4. Now I need this vertex, so we're going to write it in. I'm just substituting into the point slope form. I like to think of it as a point slope form because it's basically the same idea. The only difference, of course, is that we're using, h and k instead of y, x1, y1, but it's the same thing. So y equals 1/4 x minus 4. Be careful, that h has to be subtracted, and then we have to add the y, but that's minus 1. So there it is. Y equals 1/4. We've got an x minus 4 inside the parentheses. Squared. And then we have a minus 1. Looks good. I just want to look at it without all the marks in there. Let's see. Looks okay. And if we put in the 4, we get the -1. And if we put in the 9, we do get the 21/4. Yeah. Okay, I've gone over my 30-minute time limit, but I'm going to do one more. Now, don't be afraid of the fractions. They're not that scary. I'm going to go ahead and do this one a little bit slower just so you can see it. So I'm subtracting my y's. The equation I'm using, by the way, is y minus y1 equals a times x minus x1 squared. You could think of this as h and k as well, where this is your x and y. Doesn't matter, it's the same thing. So I'm taking negative 2/3 plus 2. Maybe I'll put the minus negative 2 just to be, very consistent. The x is 3 minus negative 1 quantity squared. Okay, so I put everything in there this time. So this is really 2/1. This is really an addition. So that really is 6/3, isn't it? So if I multiply by 3, I get 6/3. And when I add negative 2, I get 4/3. This is 4 squared is 16. And I have to multiply by 1/16 on both sides. And I get 1/12 for A. Okay, so if A is 1/12, or M, I sometimes think of it as M, and Y is equal to the 1/12 times X plus 1. Remember, we are subtracting a negative 1, so that's really plus 1 squared, and then we're adding the K, so it's minus 2. And there it is. Y equals 1/12 parentheses x plus 1 squared, and then we have a minus 2. And let's just make sure it looks pretty, and it does. And I could test both solutions. The negative 1 just gives me 0 in this part right here, so it's easy to test. If I stick a negative 1 for x, it gives me a 0 for all that, and my y is negative 2. So there's my first solution. My other solution is 4 squared. It gives me 16/12, and that's really 4/3. And when I subtract 2, I get the negative 2/3. So it does look good. And maybe I'll do one more. Oh yeah, there's an ugly one. So let's do this last one. Again, a lot of people are just going to grab their calculator and do this. That's okay. I think it's better to play with the fractions, but there we go. So I'm going to do 153/8. I'm going to use my shortcut. So instead of adding 2/1, I'm actually going to add 16/8. This is the same thing as 2, isn't it? And that's equal to A times negative 15. And remember, we're subtracting negative 2, so that's plus 2, quantity squared. And there's my A times negative 13 squared is 169. And there's my 169/8. And I'm going to multiply by 1/169. I imagine these fractions are pretty ugly looking as decimals. And that gives me 1/8 for my A. So I've got, there's my vertex. So I've got y equals 1/8 x plus 2 quantity squared. Don't forget the minus has to stay. There it is. So this will be our last one. Y equals 1/8 parentheses x plus 2 quantity squared. And then we have a minus 2. Make sure it's, since it's my last one, I'll test it real quick. It's looking good. Yeah, I think it's right. So hope you guys get a little further than I did. Getting lengthy here, so I'm going to go ahead and leave it at this one. So this will be my last one. So good luck, guys. Have a good day, and I'll see you back again. Bye-bye, everybody.